access protocol, control access protocol. Now I am going to explain in this video channelization protocol. Under that there are three types: FDMA, TDMA, CDMA. What is meant by channelization protocol? We shall discuss on the type of the channelization protocol. Channelization protocol, it is a multiple access method. It means the available bandwidth of a link is shared between the different stations through time frequency code. Means they are telling the available bandwidth of the media is shared by the different station connected to the medium through, means depend upon their time frequency and code. Means this is on media, means this is shared by 4 station, 1 2 3 4. This is media, this is, there are 4 stations. These 4 stations are going to share the bandwidth of the media. Okay, this bandwidth of the media is shared by this 4 station through time frequency and code. Okay, so there are 3 types of protocol used in channelization protocol: FDMA, TDMA, CDMA. Frequency division, multiple access; time division, multiple access; code division, multiple access. We shall discuss FDMA first. Okay, FDMA, frequency division, multiple access. The available bandwidth of a media is divided into frequency band. Okay, each band is reserved for a specific station. Each station can send the data in a allocated frequency band. Each station use the band pass filter to confine the transmission frequency. Means next, use small guard band are used to separate the allocated frequency band from one another. What do you mean by this statement? Means you can see that this is the frequency division multiple access diagram. You can see that this is the channel. These are the 4 stations, 1 2 3 4. Okay, this bandwidth of the channel, means bandwidth of the media, is divided into 4 frequency bands. Means bandwidth of the this media is divided as 4 frequency band. This color band is reserved for station 1. This yellow color band is reserved for station 2. This white color is reserved for this third station, and this color band is represented for 4 stations. Suppose the station 1 send the data, means in first frequency band it will be allocated, and this color means second frequency band allocated for the station 2 data. If station 3 is sending the data, means white color frequency band for the allocation of data. This yellow color is reserved for data from the station 4, and we can see that in between this 4 frequency band there is a small gap. Okay, this gap is called as guard band. To separate one to another frequency band, we are using the small band that is called as guard band. This is guard band. This is 1 2 3. 3 guard bands are there. So to separate the between one frequency band to another frequency band. Okay, and they told that each station use band pass filter to confine the transmission frequency. Means each station will have the band pass filter. Means each station will have the band pass, means 1 2 3 4 station will have the band pass filter to confine the transmitter frequency. Means it will keep the what the frequency need for the transmission, it will keep by this filter. Okay, this is the explanation of FDMA. And there is a difference between FDM and FDMA. FDMA means frequency division multiplexing. Means frequency division multiplexing is a multiplexing method in the physical layer. Okay, next FDMA is a axis method in the data link layer. We know that we discuss frequency division multiplexing. What this frequency division multiplexing will do means, frequency division multiplexing combines the individual loads. Loads is nothing but data. Okay, loads is nothing but data. Individual data from the low bandwidth channel and transmit the aggregated, means combined data. Aggregated data means combined data. Combined data by using the high bandwidth channel. Means it going to convert individual data from the low bandwidth channel and it is transferred to combined data. Means first individual data ಬರುತ್ತೆ, ಅದನ್ನೆಲ್ಲ ಕಂಬೈನ್ ಮಾಡುತ್ತೆ. It will give aggregated data. This is individual. These are individual data from the low bandwidth channel and we will get the aggregated data from high bit using high bandwidth channel. Individual data from the low bandwidth channel. Okay, these are the low bandwidth channel. Okay, containing individual data that is going to convert it to aggregated data using, this is the high bandwidth channel, that is the FDMA. FDM, frequency division multiplexing. What is FDMA? Frequency division multiple axis. This is present in the data link layer. In each station, data link layer tells the physical layer to make a band pass signal from the data passed to it. Means it will tell from data link layer to physical layer to make a band pass signal. Signal must be created in a allocated band. Means the band pass signal should be created in the allocated band itself. Okay, there is no physical multiplexer at the physical layer. Means there is no multiplexing in the physical layer. Okay, next, signal created at each station are automatically band pass filtered. They are mixed, they are sent to common channel. Okay, then they are going to mix the information and they are going to send for the common channel. Okay, you can see that in upcoming topic how it going to combine, I will explain. Okay, this is the end of the FDMA. We know what is meant by FDMA and difference between FDMA and FDM. Okay, next we will move on to TDM. Okay, next one is TDMA, time division multiple axis. The station share the bandwidth of the channel in time, means they are, and here each time slot is reserved for a specific station, means in FDMA the bandwidth of the channel is divided into frequency bands. Here the bandwidth of the channel is divided into time slots. Okay, each station can send the data into allocated time slot. Okay, I will explain to the diagram. You can see that this blue color represent the station 1 reservation of time slot. Here this is time slot of 2 station. This white color is reservation time slot of this station 3. This yellow color reserved time slot of station 4. Okay, it is the time division method, means the bandwidth of the channel is divided the time, okay, converted into time slots. Okay, and here the station 1 data will be sent to this time slot, and station 2 data will be sent to this orange color time slot. The station 3 data will be sent to white color time slot. Station 4 data will be sent to yellow color time slot, and this will be combined and this will be sent to common channel. Okay, and there is a main problem here. In this TDMA there is a one main problem: achieving synchronization between the different station. Means achieving synchronization means matching between the different station is the main problem here. That is, each station need to know beginning of its slots and location of its slots. Means each station should be know their beginning of the slot and the location of the slot. Okay, this is very difficult. Knowing the beginning of the slot and the location of the slot is very difficult, because propagation delay introduced in the system. Propagation means there will be some waiting time for the individual station, that will be not synchronized. So the propagation delay of one station to another station is very different. So to overcome this, we use guard time. To overcome this propagation delay, we are going to use guard time. What is guard time? Means we are going to give the some extra bit for the beginning of the slot, that is grid time. Okay, next we will discuss what is the difference between TDMA and TDM. TDMA means time division multiple access. TDMA means time division multiplexing. Okay, the TDM is multiplexing in physical layer. What this TDM will do, it going to combine the individual data from the slower channel and transmit the aggregated data by using faster channel. Means it going to combine the individual data using the slower channel and transmit the aggregated data, means combined data, by using faster channel. That is the use of the multiplexing of TDMA. Next, what is meant by TDM? Time division multiple access. This is the access method in the data link layer. This is in the physical layer. This will be in data link layer. In each station, the data link layer tells the physical layer to use the allocated time slot. Means what this TDMA will tell means in each station the data link layer tells to physical layer to use the allotted time slot. Means they will give the information that each station should use from data link layer tell to physical layer to use allocated time slot. Okay, no physical multiplexer at the physical layer, because here only we allotted this time slot, so there is no need of here physical multiplexer. Okay, so here only in each station, here only they will give the information from that data link layer tells to physical layer to use the allocated time slot, because there is no extra physical multiplexer at the physical layer. Okay, this is the end of the TDMA. Okay, next we will move on to CDMA, code division multiple axis. Okay, CDMA simply mean combining with the different code. It is nothing but the data will be combined with the different codes, that is CDMA, code division multiple axis. Okay, CDMA is different from the FDMA. Means FDMA will be differ from CDMA. FDMA. How only one channel occupies the entire bandwidth of the link. Okay, here only one channel occupies the entire bandwidth of the link. Okay, next CDMA differ from TDMA. How it is differ from the TDMA? Means our station can send the data at a time. There is no time sharing. This is the differ from CDMA to TDMA. Means our station can send the data at a time. There is no time sharing. To overcome this, we are using CDMA. What is meant by CDMA? CDMA is nothing but simply combining the data with the different codes. Okay, we are going to combine the data with the some codes. They are only, that is only they are telling, simply means communication with the different codes. Means we are going to multiply the code with some data with some codes, that is code division multiplexing. How it will happen, you can see here. This is the CDMA, station 1, station 2, station 3, station 4. Okay, this is the data is encoded into D1. Okay, D1 come to here. This D1 will be multiple with the code C1. Next, D1 data will be encoded to D2. Data station 2 data will be encoded to D2. D2 will be multiplexed with some code, like that only. Here same way. Then what we are going to do, after multiplexing with this data with their codes, then we are going to add this, and this is the final data we send to common channel. First data ಬರುತ್ತೆ, data ಇಂದ ಕೋಡ್ ಯೂಸ್ ಮಾಡಿಬಿಟ್ಟು ಅದನ್ನ ಮಲ್ಟಿಪಲ್ ಮಾಡ್ತೀವಿ. ಸೇಮ್ way we are doing here. After getting this I am going to add year to year, and year to year. That is the final data we are going to get. We are passing to common channel. By taking example, I am going to explain this CDMA. Okay, what is chips? I told that this is the code we are going to multiply with data. What is this code? We are going to explain now. What is C1, C2, C3 and C4? Here you can see that each station is assigned a code. Each station is assigned a code which is a sequence of number called as chips. You can see that this is the code C1, C2, C3, C4 are the codes. These are the sequence of number +1, +1, +1, +1. These are the sequence of number. This sequence of numbers are called as chips. This is one chip, this is one chip, this is one chip, this is one. Okay, you can see that this is the code C1 multiplied with D1, this C2 will be multiplied with D2, this C3 will be multiplied with D3, this C4 will be multiplied with D4. Okay, this sequence of numbers should be different from one code to another code. You can see that this is differ from this 2 is differ from this 3 is differ from this 4th one. Means the sequence of number should be different from one code to another code. Okay, next data representation. How we can represent the data? We follow the following rules for the encoding. To send 0 bit, a station encode the bit as a -1. To send 1 bit, a station encoded the bit as +1. The station is idle, means the station having the no data to send, means it send a no signal. It will not send any signal. This is interrupted as 0, means it is represented as 0. Means they are telling if it is having the bit 0, we are going to represent it as -1, means we will encode it as 1, -1. If we are having the 1 means bit, we are going to encode it as +1. There is silent, there is no signal, means we are going to give it as 0. Okay, using this we are going to give the data. We are going to give the data year, okay. This data will be converted to D1, D2 to data to D2, like this. How it will be converted, we are going to see now. Sharing the channel with the station. You can see that there are 4 stations, 1, 2, 3, 4. Okay, the station having the bit 0, it is encoded to -1, because I told that 0 bit will be encoded as -1. Here also 0 bit will encoded by -1. There is no signal, means it is represented by 0. Bit 1 is it is represented by +1. Now I have to multiply this this encoded number -1 with the code. Here also this will be multiplied with this codes. This 0 will be multiplied with code C3, and this will be multiplied with C4. -1 into +1, we are going to get -1 minus 1 into plus 1 minus 1 minus 1 into plus 1 minus 1 minus 1 into plus 1 minus 1. Next minus 1 here, minus 1 into plus 1 minus 1 minus 1 into minus 1 plus 1 minus 1 into plus 1 minus 1 minus 1 into minus 1 plus 1, like that. 0 is multiplied with this code. Anything multiplied with 0 means you are going to get 0 0 0 0 here. Okay, here we are having plus 1 as a encoded code. This will be multiplied with codes plus 1 into plus 1 only, plus 1 into minus 1 only, plus 1 into minus 1 only, plus 1 into plus 1 only. Okay, now we have to combine this multiply data and code, so we are going to get the final data, means this data we are going to get. How we are going to add, means first bits number we are going to add and store here, like minus 1, like first minus 1, your first number minus 1, next your first is 0 plus 0, next here plus 1, means we are going to get minus 1, next minus 1, this bit minus 1 plus 1 plus 0 minus 1 is equal to minus 1. Next third number minus 1 plus 0 here minus 1 is equal to minus 3. Next minus 1 plus 0 plus 1 is equal to, we are going to plus 1, means we are going to get minus 1 minus 3 plus 1. Okay, this is the combined data. You can see that minus 1 minus 3 plus 1 as a combined data. Okay, next this minus 1 minus 3 plus 1 can be represented as a signal. You can see that this is the final signals, combined data of all four stations. Minus 1, this is minus 3 because this is bigger than last two signals. Okay, because this is minus 3 and plus 1, means you can see that this is minus side, this is plus side. Minus 1 is here, next is minus 1 here, next minus 3 here, because minus 3 is bigger than minus 1. So next plus 1 is represented here. Okay, this is the digital signal created by 4 stations in CDMA, means time division multiple axis. Suppose station 3 wants to listen to station 2, means the station 3 is silent. The station 3 wants to listen to station 2, means it have to communicate to station 2 data, so that to do this process we have to multiply this whole combined data with the code of C2. Okay, this is multiply with this one, and we should get the final result as encoded data minus 1. Okay, we shall see that minus 1 minus 3 plus 1, this is data, combined data. Okay, this is multiply with the C2 data. You can see that plus 1 is there, minus 1 is there, plus 1 is there, minus 1 is there. Now I have to multiply with this number, first bit with first bit, second bit with second bit, third bit with third bit, fourth bit with fourth bit. Okay, now minus 1 into plus 1, minus 1, minus into minus means second bit, second, minus into minus plus 1, minus 3 into plus 1, minus 3, plus 1 into minus 1, minus 1. So we are getting minus 4 divided by how many station? This 4 represent the station. You can see that here this is 4 station, 1 2 3 4, 4 station. Okay, minus 4 divided by 4 means you are going to get minus 1. You can see that here you are going to get this minus 1, then it will be converted to data 0. We got the answer. Okay, now want to listen for the station 1 means you have to multiply this C1 with to data, then you are going to get minus 1. Minus 1 should be converted to 0 bit. Like that you have to listen to 4 station means you have to multiply this C4 code with this data means you are going to get final as plus 1. This is converted to bit 1, like that only. Okay, next last concept is general rules and example for creating partial tables. How this partial time is created means you can see that there is this one represent the number of station. Okay, you have to multiply. Okay, 1 into 1, you are going to get one element means the number of row, number of columns should be same. Here 1 into 1 row and you are going to get one element. Next you can see that here there is a 2, W2 means you have to multiply 2 into 2, you will get 4 elements. You can see that 1 2 3 4. Next W4, 4 into 4, 16 element you can fill. How these elements going to fill means you can see that first only one station having the one station sharing the medium means there is one station means one element. Okay, you can fill plus 1 or minus 1. Okay, next you have to fill for the 2 station means we see that station there are 2 station means we are filling 4 elements. Okay, here this plus 1 will be 4 first station, second station, third station, fourth station. Complement of this 3 station means minus 1 means here you can see that here plus 1 plus 1 plus 1. You can see that complement means opposite to these 4 numbers you are going to get minus 1. Okay, like that 4 means 16 element, 4 4 are 16. Here I will make 4 separate boxes. Okay, separate boxes. Here in this box I am going to fill these elements like plus 1 plus 1 plus 1 minus 1. See this type, no, same this element will be filled here plus 1 plus 1 plus 1 minus 1. Next Next here also same, plus 1 plus 1 plus 1 minus 1, but this is the this fourth box is complements of this three box, means here plus is minus, here minus, here minus, here plus. Okay, this is the complement of this three elements. Next I told that C1 C2 C3 C4 ಹೆಂಗೆ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಬೋದು. C1 is nothing but first row, C2 is second row, C4 is C3 is third row, fifth row. You can see that I will show. Okay, you can see that plus 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 plus. Next plus 1 minus 1 plus 1 minus 1. This is second code. Third code plus 1 plus 1 minus 1 minus 1 plus 1 plus 1 minus 1 minus 1. Next fourth code plus 1 plus 1 minus 1 minus 1 minus 1 minus 1 plus 1. This is washup code. Nothing but what is the code we are having, that is the complement of this last code, that is washup method. Okay, this is the end of the second chapter of fourth module. Okay, bye.